this? We saw that there exists open set such that okay. Once this is proved, the only if part of the theorem is valid. Okay. So for every point in this pre-image, by the definition of this pre-image, we see the FA less than C. So FA less than C, using the continuity of F, at this point A. What this means? This means for epsilon equal C minus FA, which is positive, there exists delta. This delta will depend on A, therefore we denote it by delta A, such that delta is positive, such that if x, the distance from x to A is less than delta A, this means x belongs to the delta A neighborhood of A. Of course, x also need to take from A. For such x, the difference from fx and fa will not greater than this epsilon. This exactly implies that fx is less than epsilon plus fa. This is C. Okay, so the continuity of F, the role that the continuity of F played in our argument is this. For every A, we find this delta A. In summary, by the continuity of FA, there is this delta A positive such that Fx less than C for all x in this neighborhood of A and from A, the intersection. What's this? This implies that B delta A intersect with A is contained in the pre-image of this open interval. Okay, remember this. We will use this later, and I will copy this to the next page. B delta A intersect A contained in the pre-image of this. Okay, and this is true for every A. Every A in the pre-image such a delta A positive. Okay, now how to get our open set U? The set U is given in this way. Let U be the union of all these balls. For every A run through this pre-image. For every A, this is the pre-image, and for every point A here, we have a ball. This is A. The radius of this ball is delta A. For every A in this pre-image F inverse minus infinity C, we have this delta A, and we have this ball, and all the union of all these balls, we denoted it by U. So U is open. U is open because the balls are open, and a family of open, the intersection, the union of a family of open sets still open. Therefore, this is U is an open set. And let's see this pre-image. This pre-image, of course, is the union of a single point. Okay. Every set can be considered as a union of some single point set. This single point set consist of the points, every point in this set. Okay, so this is a very easy equality about the equality of sets. Okay, but this point obviously because A belongs to the pre-image of F, implies that A belongs to A, because F is a map from A to R, right? So we must have A obviously is belongs to A for every such A in the pre-image of minus infinity C. Therefore, also A as the center of this ball, A is a point in its neighborhood. So we have, this will be a subset of the set in the union. Okay, because our A here is a subset of this. For every A, the single point set is a subset of the intersection of this delta A neighborhood of A and set A. So the union also is a subset of the union in the right hand side. But for the right hand side, look at this. For the right hand side, every set in the union is a subset of the pre-image of this. So the whole union must also be a subset of this, right? So we have the union. Every term in the union is a subset of this set. So the union of the family must also be a subset of the same set. So we see that the pre-image of minus infinity C is contained in this union. And in turn, this union contained in the same pre-image, which implies that this union is exactly equal to the pre-image. Okay, remember this. I will write this next page. Is exactly okay. Oh no, sorry. Okay, so we have this. But the right hand side can also be written as this. We take the union of the ball first, then intersect with A. But the union of the balls is exactly our C, our U. So this is U intersect with A. Therefore, we have proved that the open set U we choose, whose intersection with A is exactly the pre-image of minus infinity C. So this prove our claim previously. This prove our previous claim we need in our previous argument here. Okay, so similarly we can get an open set V. So this means that the only if part of our theorem is proved. Now we prove the if part.